Let's have a look at IP addresses. So what is an IP address? Okay, so first of all, we need to understand what is IP. IP is what we call the Internet Protocol. Okay, now if you guys remember back to a previous lesson, we learned that IP is part of TCP/IP. It's one of the main components of the TCP/IP protocol. And IP is exactly responsible for addressing. Okay, now not just special or any type of addressing, it is what we call logical addressing. Okay, because remember we also talked about at a earlier stage, we talked about physical addressing, and we learned that the physical address is the MAC address. So now IP or an IP address is when we start talking about logical addressing. And what is logical addressing? Logical addressing is what we call network addressing. So it's giving an address to the network so that we can find different networks. Now, the easiest way to explain what is an IP address and why an IP address is important is to, of course, relate it to something that you guys all know. And I'm pretty sure you guys all know when we start talking about streets and houses on streets. Okay, so let me do a quick little drawing here of a couple of ugly houses, but at least we can all see that they're houses, of course. So here we have a typical street. We have two streets. Let's call this one Banana Avenue, and this guy over here will be Apple Street. Okay, so two streets. In these two streets, and let's make them like so. So we've got blue over here for banana, and let's say we've got yellow over here for Apple Street. And of course, each one of these houses will have a number. Okay, we all so far with me. Hey, very simple stuff. Now, I want to send you a letter, and you live over here in this house. This is where you live at the moment. I'm an old school, your pen pal, and I want to send you a letter. So I have to write an address on the envelope so that the postman can find your house. And of course, the address that I'll write at the moment will be 1 Apple Street, and then the suburb, and then the town, which we don't really care about at the moment. This tells the postman that to find this house, he will have to go and walk down Apple Street, and when he's in Apple Street, he has to go and look for the house called number 1. Okay. Not this house, which is also number 1, but this guy is number 1, Banana Avenue. So by looking at the address, the postman can find out both the street that the guy lives in and the house number on that street. Okay, now that's what we then call the address. So now let's take the same thing and we convert it into networks. So now we've got LAN A, LAN B, LAN C, and LAN D. You've got a computer here in LAN D, and you want to send data to a computer in LAN B. So how do we send that letter? How do we send that data? We first need to find the right network, and once we find the right network, we then need to find the right PC. Think of the network as the street that we need to find, and think of the PC as the house that we need to find. So we need to have an address that we can send this so that we can first of all make sure we got the right network, and then once we're in that network, find the right PC. Just like the postman has to find the right street, and once he's in the right street, he has to find the right house. Now, the address that we will use to send that is called the IP address. The IP address will have a layout, okay, of what it will look like. We'll talk about what they look like just now. But part of this address will tell the postman the street that you need to find, or the right LAN. And then once he finds the right LAN, another part of that address will make him find the right house or the right PC inside of that address or that network. So this is where your IP address is very important, because it tells other networks, other computers, both in what network you're located, but then also in what PC in that network you are located, and where does the data have to go to. Okay, so let's have a look at an example of an IP address. Okay, so an IP address example is something like this. Oops, okay, sorry, no, not that. I made a mistake there, sorry. So it looks something like this. Okay, so what is this number? This is a 32-bit binary number. So remember, binary is a whole bunch of ones and zeros, eh? Where this 32-bit number is broken up into 4 octets. Okay, now what do we mean by 4 octets? The word oct, for those that don't know, stands for 8. So what we've done is we've taken a 32-bit number and broken it down into 4 8-bit sections. Okay. So it's 32 bits all together, but these 32 bits are broken up into an octet, where we basically take 8 binary numbers and we group them. So it's 4 groups of 8 numbers together, making up an IP address. And then each one of these 8 numbers or octets is then converted from binary into something we call decimal. And why do we use decimal? Because we as humans like using decimal to read and write and remember things, because it's easier for us to remember that number than what it is to remember that number. Okay, imagine if you have 100 computers and you need to remember the IP address of each computer, but you have to remember it in an IP address or a binary format. Most of you most likely don't even remember your cell phone number for your best friend. So how are you going to remember 32-bit, 32 numbers for one device, and then have 100 devices that you need to remember the IP address for? So it's easier for us to convert the binary IP address into decimal so that we as humans can better remember it, understand it, and use it. But the computer uses binary. It uses the ones and zeros. Okay. So what this will look like then. Let's say again I have my 4 networks. Okay. And I'm just using examples here. We'll go to a bit more detail just now. So this network will have to have a network ID. Okay. That IP address, part of it has to be assigned to the network itself. So let's say that network is 192.168.1. This network must be unique. So this guy must be 192.168.2. Okay. This guy must be 192.168.3. And this guy must be 192.168.4. Every number must be unique, just like we have separate streets. We don't have 2 streets with the same name in the town. You know, the town all have unique street numbers. And then the computers inside the network must also have an IP address, but because they're sharing the same network, the network portion must be the same, but they each must have a unique ID to distinguish themselves from one another inside the network. So if we continue our things, this is an example of what IP addresses might look like when you're discussing multiple networks and multiple PCs inside that network. Okay, let's just finish down here as well. .4.1 and 192.168.4.2. So the network ID always stays the same, but the host ID is unique for every host inside that network. So now, if we say that computer A wants to send data to that guy over there, it will say, okay, here's the packet. The destination address will be 192.168.3.2. Remember the IP address assigned to that guy, hey? The devices in the network will then see, oh, okay, I need to send it to network 192.168.3. So it needs to go to that network, not that guy or that guy, because they've got different network IDs. And once it's inside the network, it then says, oh, I need to look for computer.2, which will then say, oh, that's the computer.2, and that's where data needs to go to. Okay, so that's why we have IP addresses and why IP addresses are so important when discussing networks. We need to find the right network, and all the networks all over the world need to be unique. They need to have a unique street so that if I'm sending data to, let's say, Jared on his network, I'm not sending it to Bill Gates because Bill Gates will have a different network than what Jared will be in. So this allows the devices on the network to first find the right network, and once it finds the right network, to find the correct PC inside of that network.